Today we are looking at the pre-calculus lesson for chapter 1.4 titled Combinations of Functions. Make sure you put your first and your last name and what period you're in your notes. All right, for the first slide, we're going to be talking about the arithmetic combinations of functions. So in this example, if the function of x is equal to 5x minus 4 and the function of g of x is equal to x squared plus 3x plus 6, we're going to do the following. So notice we're going to add, we're going to subtract, we're going to multiply, we're going to divide. Okay, so for part A, we're going to take the function of x and we're going to add it to the g of x. So f of x is 5x minus 4. We wrote that right here. We're going to add, so I put a plus sign. G of x, which is x squared plus 3x plus 6, and I wrote that right here. And so we just add them together, combine any like terms if we have any, and simplify if possible. All right, there's only one x squared, so I wrote that first. Then there was a 5x and a 3x, that gets us 8x, and then a negative 4 plus a 6, so that's plus 2. All right, part B, now we're going to subtract. Okay, subtracting is like adding the opposite, so I'm going to write subtraction in here, but then I'm going to write the g of x in parentheses. So you can think of it as distributing that negative sign here, here, and here, if that helps, or just add the opposite. Okay, so when we take the f of x, which is 5x minus 4, we subtract the g of x, which is x squared plus 3x plus 6. The only x squared we have is right here, and there's a negative sign out front, so it's negative x squared. Okay, then we have 5x minus the 3x, that's how we get plus 2x. And then a negative 4 minus the 6, which gets us to negative 10, or minus 10. All right, part C. Now we're going to multiply, but instead of leaving our x's as x, we're going to plug in negative 3, and we're going to plug in negative 3. So for the f of x, we're going to take 5x minus 4, but we're going to plug in negative 3 for x. We're going to do the same thing for g of x, but we're going to plug in negative 3 for x. So we're actually going to get a numeric answer on this one, and we need to make sure we follow order of operations. Okay, so we have two huge sets of parentheses, we have some exponents, we have some multiplying, and some adding and subtracting. Okay, so for this first set of parentheses, we're going to multiply first. 5 times negative 3 is negative 15, and negative 15 minus 4 is negative 19. For the second set of parentheses, we have this exponent, so negative 3 squared is 9, and then we have multiplication. 3 times negative 3 is negative 9, and 9 minus 9 is 0. 0 plus 6 is 6, and then the last step is to multiply these two guys right here. So negative 19 times 6 is negative 114. Part D, now we're going to divide, and we're not just going to leave the x in there. This time we're going to plug in 2. So we're going to take the f of x, which is 5x minus 4, plug in that 2, and divide it by the g of x, and plug in the 2 as well. So 2 squared plus 3 times 2. Plus 6. And again, we need to just be careful to follow order of operations and simplify and reduce as much as possible, right? So we're going to multiply first here. 5 times 2 is 10, and 10 minus 4 is 6. And then here we have an exponent and multiplication. So 4 plus 3 times 2, which is 6. So 4 plus 6 is 10, and 10 plus 6 is 16. We get 6/16. I can actually reduce that to 3 over 8. All right, so for the next slide, we want to let f and g be two functions with overlapping domains. Then for all the common, all x common to both domains, the sum, the difference, the product, and the quotient of f and g are defined as follows. Okay, so it can be written as f plus g of x. That's going to be the same of the f of x plus the g of x. Or it can be written as a difference. F minus g of x can also be written as f of x minus the g of x. Same thing for the product, same thing for the quotient. Okay, so here's some examples And again, we've got a new f of x and a new g of x. And for A, we want to add them. For B, we want to add them. For C, we want to subtract. And for D, we want to multiply. For A, we're just going to leave the x, the variable x, in there. And so the f was x squared plus 1. That's right here. And the g of x is x minus 4. That's right here. So we add them. Here's our only x squared, so just rewrite it. Here's our only x, so just rewrite it. And then we have a 1 minus a 4. Combine those two together to get minus 3. Okay. Part B, we're going to add again, but this time we're going to plug in 4 everywhere we see x. Or since we already added them over here, we can just plug in 4 here and here. So I'm going to plug in a 4 here and get 4 squared. Plug in a 4 here and get plus 4. And then minus 3. 4 squared is 16. 16 plus 4 is 20. 20 minus 3 is 17. All right. Part C, we've got f minus g of x. So I'm going to start with the f, which is x squared plus 1. I wrote it right here. Minus the g of x, which is x minus 4. Notice that I wrote it in parentheses, so I remember to distribute. And so here's our only x squared term. Bring it down. And then inside the parentheses, we have this x, but out front of it, we have a minus, so it's minus x. And then we have 1 minus minus 4. Minus minus should be plus, so 1 plus 4 is 5. Part D, f times g. Okay, so we have the x, oh, and we need to plug in negative 3. All right, so we're going to plug in negative 3 into the f, so negative 3 squared plus 1, and then we're going to plug in negative 3 into the g, so negative 3 minus 4. Simplify your parentheses first, then multiply them, right? So negative 3 squared is 9, 9 plus 1 is 10. Negative 3 minus 4 more will get you negative 7. Now multiply them, get your negative 70.